command actually. I think we already discussed this and used many times. So basically, we use this command effectively to test the connectivity. It used the internet ICMP to verify the layer 3 connectivity. Ping command can be helpful to identify the source of the problem. Ping command issue from the iOS will yield one of the several indication, and this is the indication. You can see the first one is mean thumbs up, indicate receipt of the ICMP echo reply. So there is an echo, like the source is sending the echo, and the other guy, they are sending the echo reply back. And if you see the dot one, indicate that time expired while waiting for the ICMP echo reply. So your message is reaching, but the other guy is not able to reply you back. And you indicate that ICMP's unreachable message was received. So means your message has not been delivered. So in the Cisco router, as compared to the Cisco, if we go into the computer and open the command prompt. So let's say on the command prompt, I say ping.a.a.a. So when I ping that, you see I'm getting the reply. So my machine, this computer is sending the echo, and Google server is sending the echo reply back. So this result is different when we go into the Cisco router. So you can see on the Cisco router, what we have three types of indication. One, successful, you send the echo and you get the echo reply back. Dot indicate that time expired while waiting for an ICMP. U mean indicate that the ICMP's unreachable message was delivered. I'm not sure. Now, this is we already discussed that. So for example, on the Cisco router, if we go into our topology, so our topology has this topology, like if I ping to 10.1.1.1, yeah. So you can see I am able to reach to this server, and 10.1.1.2, I am able to reach the TFTP server. Okay, what is extended ping? Extended ping. Okay, this is a long time ago. Somebody asked me this question in the interview. What is the extended ping? So when you do a normal ping on a Cisco router, just one second. Extended ping. So in the extended ping, normally when we send the ping, actually, look at if I ping right now from a machine. If I ping from my computer, look, when we do the ping from the machine, and if I do just like ping 8888 on the computer, normally we get 4 ping reply until we say -t. With the -t, what happens? It just continuously pinging it. Sometimes for the troubleshooting purpose, sometimes for the troubleshooting purpose, we use this. So when we normal ping on our computer, we ping it finish after 4 pings. But when we do ping -t, continuously pinging, as you can see. So sometimes for the troubleshooting purpose, you continuously ping on the other side. Okay, so Cisco routers can give you the flexibility. If you just normally ping on the Cisco router, like here, you see it finish after 5 pings. After 5 pings is finished. However, the extended pings give you more option. If I say ping only, you can see with a ping, which protocol you want to use. Ping, IP, target host 10.1.1.2, our TFTP server. How many pings you want to do? So the default pings are 5. Let's say I say 100. That datagram size. What will be the size of the packet? Sometimes for the troubleshooting purpose, we can change the packet size. By default, the packet size is 100. But let's say you are trying to troubleshoot something, you can say the packet size will be 1500 bytes. Okay? Timeout. Normal default timeout is 2, but you can take the timeout like 5. Extended command. If I say yes, it gives you more options. So basically, you can see normal ping and extended ping. There's a difference. In the extended ping, for advanced user, people like you, those are network engineers, they can actually play around with the other option. Like what will be the source IP, or what will be the size of the interface, or sorry, size of the packet, how many ping. Because by default, there are 5 ping, you can extend, increase it. You can change the packet size. You can go for, and you can see now the source interface. Any interface, type of services you can use, DF bits you can set. DF is the defragment based. Basically, it said do not normally when the packet is traveled from one interface to another interface. Sometimes we make the big packet into the small one. Fragment. We make small packets, and on the other side they defragment again. So basically, do you want to defragment bit on? Why we use in some cases? Let's say we are troubleshooting an interface where we want to check the packet size, what is the maximum packet size can go from it. So if you say, I want to send the packet size of 1500, do not make this packet size small, maybe 500, 500, 500 each. I want this packet size should be 1500. So I can check what is the maximum packet size it can go from the interface. Okay. So if you don't want to, so look at this now. There are many options. Now you can see as compared to the previous ping, extended ping give you the option one by one. It asks you what you want to change. You want to change the packet size, how many packets, like by default 5 packets, but maybe 10, 1500. Which interface you want to use. You want to use DF bit, you want to choose the packet size. So many options it gives you. So this is called the extended ping. Extended ping sometimes used for the troubleshooting. So you see a series of prompts are then presented, pressing enter to accept the default value. Okay. So sometimes for the ping command, you can use the baseline. Baseline means when the network is laid down, you can actually check that what is the time, millisecond. I think I explained you before what is a millisecond. What is a millisecond by the way? Look, when you ping this host, what is this? 1 millisecond. It means the packet is going from source to the destination and return back as well. The time it takes from the source to reaching to the destination and returning back, that is called RTT, round trip time. Okay. So for example, if you go to Heathrow and the time will count from going and coming back, this is called your total number of hours. So 1 hour goes and maybe 1.5 hour come back. That will be total of 2.5 hour. Okay. So when you send the packet from your source machine to the destination, how much time does it take? Like for example, you need to tell me how much time we are taking right now from here. What is the RTT here, guys? You see it's changing. So from my machine, from this network reaching to the DNS, Google DNS server, how much time it takes? The total. That is called RTT and it is measured in milliseconds. Right? So sometimes you take the baseline that, okay, initially when we laid down the network, initially when the internet installed, this was the baseline. We can create a document that say, okay, initially the RTT was maybe 1 second, but maybe after that sometime, you see that's why February 2013, at this time it was 1 millisecond. However, now for the same destination, it is 6 milliseconds. So it means something is changed which increased the time from 1 millisecond to 6 milliseconds. Clear?